So I will not be theoretical today, so you hardly see me in the slide. Let me give you a background of what I want to demonstrate. I want to create 3 different types of access lists, or let me say 2, and then the last one will be named. So the first one is going to be standard access list. I want to demonstrate how do we make use of standard access list, how we create it, how we make use of it. I want to teach how to create extended access list and how we make use of extended access list. Then the last one, we're going to go to named access control list. Don't forget, we have said access list, whether extended or standard, it's a statement, list of statement permits, list of statement of permit or deny. So we're going to have a topology to work with today. I'm going to build a local area network having 2 different LANs connected to the router. I'm going to have a section here, maybe 200.100.0/24. We call this LAN A. We can have 200.100.101.0/24. We can call this one LAN B. So we can have people here, maybe 2 people on this LAN and 2 people on this LAN. So when we're done building our network, we make sure that these people here can ping people here before we now start putting our access list. So access list basically to deny or to permit people from going out of the network. So we're going to learn how to create the standard. We're going to learn how to create the extended. So I will just use one router. It's possible to have more than one LAN, something like this, more than one router. So it now depends on where your source is, where your destination is. That's where you go and create your access list if you have access to that router. I mentioned that in the last class. So that being said, let's go to our packet tracer and build a basic local area network. 2 LANs, and then we'll use it to demonstrate. So on this section, who's saying no sound? Are you just coming in? Mr. Oroji, can you hear me? Okay, Ali, thank you. I will stay extra 10 minutes. Still, people will still come late to class. I don't get it. So meaning the person that is just coming in and probably does not understand what I'm doing or what I've said before now. So let's go this one, LAN A. Oh, I should have even added it to that side. Let's go this one, LAN B. So I have LAN A here. I have LAN B here. This is the network address of LAN A. This is the network address of LAN B. So let me quickly configure the router to be able to help us to do routing between the 2 LANs. So I'll go to my G00, give it an IP address from that network. We have only one router. IP address 100.100.100.1. No shut down. G0/1 IP address 200.100.101.1 255.255.255.0. No shutdown. So what have I done? I just activated the interfaces of my router. So I'll go to the people in LAN A, give those computers IP addresses. And tell the guy about the gateway. I give this guy .2. I'm giving the other guy .3. Tell this guy also about gateway. Then go to the other side. Also give them IP addresses based on the network they belong to, and also tell them about their gateway. 200.100.101.2. Subnet mask. Tell this guy about the gateway. 200.100.101.1. So give the third guy .3. 200.100.101.3. Subnet mask. Give the other guy gateway. So now I've built a basic local area and a basic LAN. Let me say two basic LANs. We have LAN A, we have LAN B. So let's test for connectivity between the two LANs. Let me name this computer. I'll just tag them. Let's call this one computer A, PC A. PCB, PCC, PCD. So take a look at PCA and PCB. They belong to LAN A. PCC and PCD belongs to LAN B. So let's check for connectivity first between the LAN A and then go and try to see if we can cross border. Where am I right now? IP config. This guy is 200.100.100.2. Let's see if this guy can ping 200.100.100.3, which is another person within the same network with this guy. You see that PCA can ping PCB. So let's now see if PCA can travel out of their LAN to ping 101. We have 101.2 and we have 101.3. So PCA can go. By now, you should know the reason for this request timeout. We ping again now, everything will be successful. So let's see if PCA can talk to PCD on the other side, which is 200.100.101.3. So now you can see that we have been able to achieve. Who is talking STP? You mean the request timeout? Mr. Samuel? No. ARP, not STP. Advanced Resolution Protocol. I've demonstrated that in class before. At the early stage, when we started the program. Do you understand? If you have in my video, yes, app, yes, app. All right, so now you can see that everybody, all the computers on my network can talk to themselves. So what if we now have a situation whereby we want to block computer A from going out of this network completely? He can talk to this guy, but he can't cross border. Or we want to block computer B. Or in the long run, we can say we want the situation whereby computer A can talk to computer C, but cannot talk to computer D. Or vice versa. It cannot talk to D, or it can talk to A. You can decide, you can make decision anyhow you want it. So first of all, we are going to start with the simple one. I don't want computer A to go out of this network completely. So the question is, which of the access list am I going to use? Will I use standard? Will I use extended? Both will work. Just that one will waste your bandwidth. So I want to start with standard now. And I want to demonstrate to you how standard operates. Then later on, we're going to go to extended. And you see how extended operates. Both of them will work. So let's start it on. So I'll go to my router. I want to create access control list. And I want it to be a standard. How do I do that? I go to global configuration mode. My command, first and foremost, it is advisable for you to find out first if there's any access list. Show, what's that command? Show access list. Yeah, show access list. The reason why you need to find out first if there's any access list is because it is possible that there is an access list already operating. And so that you don't go and conflict, create another one that will conflict with what is already on ground. You need to first of all find out if there's any access list already on ground. So, and the command to do that is show access list. So when you use the show access list and you see that nothing appears from the output, that means there is no access list. So now we can continue now and build our access list. How do we build access list? We say access list. If I put question mark here, you can see the range here. We spoke about this in the last class. If I said access list 1, access list 2, access list 3, it simply means I'm creating standard access list. If I put 100, it simply means I'm creating extended access list. But for now, I want to create standard access list. What do I want to do with that standard access list? And I'm going to use, or I want to use number of 1. You can pick 2, you can pick 3, you can say 99. If I say 99 now, it's the same standard access list. What will be my next line of action? I need to put my statement. This access list that I'm creating, do I want to use it to deny somebody? Or do I want to use it to permit somebody? Or do I just want to make a remark on it? But for now, I want to deny. Deny, who do I want to deny? 200.100.100.2. Don't forget, we're particular about all the octets. And what we said in our last class, we said when you are trying to make reference to all the octets, you put a welcome as 0.0.0. So if I hit enter right now, I'm going to deny 200.100.100, then .2. Then I put a welcome as of 0.0.0. Alternatively, I can as well go down and use the word host and say access list 99 deny host 200.100.100.2. It's going to also work. Either of the statement will work for us. Now, this router is going to deny 200.100.100.2. But you don't forget what I said in the last class. If you create access list, you must apply that access list as inbound or outbound access list. Inbound or outbound. Look at me here. The guy we are trying to block is somewhere here, PCA. We want to block the guy to go out completely. We don't want it to be able to go to anybody. And we are creating standard access list. What did the rule say about standard access list? The rule says place the access list or effect the access list or apply the access list on the ports closest to destination. This is our G0/0. This is our G0/1. We have access to this router. If we are creating standard access list, where do you think we should apply it? I want you guys to type the answer for me. On G00 or G0/1? I'm watching the answers. Ali said G00. Mr. Samuel said G0/1. Others, can you please talk? G00 is our inbound. G0/1 is our outbound. What do we mean by that? It's coming in from this place here. That is the inbound. If it has gone in, it's going to go out through the other side. The other side is the outbound. And the rule says it must be placed closest to the destination. This is source. This is destination. Between these two interfaces, which one is closer to the destination? The rule for standard access list. Yes, G0/1. Ali, did you see now that you missed it? The rule for standard says it must be placed closest to the destination. The rule for standard access list. Ali, do you understand what I'm saying now? Okay, beautiful. So whenever you're creating access list, you must be careful with the type of access list you are creating. But for our own now, we are creating standard and we have to follow the rule. So out of these two ports, this is going to be our inbound interface. The other side is going to be our outbound interface. This is inbound, this is outbound, meaning the packet is definitely going to enter from this interface and go out from another interface. So we are supposed to apply our access list on G0/1. That is one. When you are applying the access list on an interface, you have to determine the direction. Is it an inbound traffic? Is it an outbound traffic? Well, I've already showed you now. Here it will be inbound. That's where it will enter from. The other side will be outbound. That is where it will go out from. So in that case, when I'm applying on an interface, I have to tell my router that I am referring to outbound traffic. If I apply on G0/0, I have to tell the router that I am referring to inbound traffic. How do you do that? Let's check it out. So we go to our router. We have created the access list. Access list 99, deny host 200.100.2. We go to the interface. We have all agreed that we're supposed to apply the access list, which is interface G0/1. The command to apply it on that interface. Yeah, once you understand the inbound and the outbound, that's all. The inbound is where the traffic is coming in from. The outbound is where the traffic is going out from. Or true. Exactly, Mr. Samuel. Good. So now, don't forget something I said in the last class. This access list we created now, we have not applied it. It's not going to do anything until we apply it. Let's try to ping from that our router again. I mean, from the computer, and see whether it will go out to people. Same computer. This is our 200.100.2 IP config. This is the guy we are trying to block from going out. So let's see if it's still going out now. We've created the access list, we are yet to apply it. So let's see if we can talk to 100.3. It's talking. What about 101.2? Let's see, it's talking. What about 101.3? It's, then we have created access list. Access list created and not applied is as good as not creating it. Access list created and not applied is as good as not creating it. And another thing I need to add to it for you. Access created and applied wrongly is as good as not creating it also. If your intention is to filter outbound traffic and you are now saying in, it will not work according to expectation. So we've created access list to block this 200.100.100.2 from going out. But the guy is still going out. Why is he still going out? Because we are yet to apply the access list. So now let's apply the access list. Based on the rule, we are going to go to interface gigabit 0/1. And the command to apply the access list is, I think it's access group, IP access group. Yeah, IP access group, take note. IP access group 99. Where is that 99 coming from? The number of my access list that I created. So this is what we tie that access list to this interface. IP access group 99. The traffic we are referring to that we want to catch, is it an outbound traffic on this interface or inbound traffic? Guys, can you talk to me? The traffic this interface now, is it going to be dealing with outbound traffic or inbound traffic? You can type outbound, and because of that, we're going to say out. If I put question mark, you're going to see now. Am I referring to inbound traffic or I am referring to outbound traffic? I am going to say out and hit enter. The moment I do this right now, that computer shouldn't be able to go out again. Let's find out. And the guy talked to 100.3. He's still talking to 100.3. Okay, let's find out. What about 101.2? What did you think? See here? Destination host unreachable. What about 101.3? Oh, no, sorry, not that one. I'm going to come and tell you something there. 101.3. 101.3. Destination host unreachable. So you see, you are not getting request timeout. Why? How come the computer is able to talk to this computer? Is able to talk to this computer. The computer doesn't need to go through the router to talk to this guy. This is 200.20.20.3. It doesn't need to go through the router to talk to this guy because this computer, PC and PCB, they're on the same network. They just need a switch to talk to themselves. But the moment the computer wants to cross border, to go to this place, to go to this place, we have blocked the computer on this interface. That's why it's not going. So what if you now don't want this guy and this guy to talk to themselves? That's a different ball game entirely. It's a different thing entirely. Some people also configure access lists on switch, layer 3 switch, to filter computers that are directly connected on that switch from talking to themselves. But what we are doing right now, it's not going to filter computers within the network from talking to themselves. It's only going to filter computers from going out of the network to go and talk to somebody on the other side. So what have you seen now? We've blocked dots 200.200.200.2 from going out. But you can still talk to the person .100.100.2 here, but you can still talk to 200.100.100.3 because they are on the same network. Let me show you something. I hope Packet Tracer will behave. What if I go to this other guy here? This guy is ipconfig 200.100.100.100.3. Can this guy talk to his neighbor, which is 100.2? So ping 200.100.100.2. This guy can ping .2 because they belong to the same network. But can this guy go out to talk to .2 on the outside? The guy can't go out. He can't talk to .2. He can't talk to .3. Why? Mr. Akindele, can you tell me why? We didn't block this guy now. We didn't block 200.100.100.3. Can you tell me why this guy couldn't go out? Try to reason it out. We need to permit someone. That's what I told you. Implicit deny. When I was teaching you guys, they will pass through the same router. Beautiful. So we have to come on that our statement that we created here ended with deny. And once the router says deny, it denies every other person. So we have to go back to that place, make that statement again, and say access list 99 permits any. That any we talked about the other time. We're not coming here now. We're not telling you to block everybody. Just block 200.100.100.2, but permit any other person. If you forget to put permits, these other person will be blocked. Now, the moment we put this statement, go back to this computer, you will see that this computer should be able to go out. The computer can go out. It can ping 101.2. It can ping 101.3. But what about the guy we blocked earlier? Can the guy, because we put permit, can the guy now cross border too? The guy still can go. The guy can go. Whenever you are creating access list, don't ever forget to come down and say permit any. Show history. Look at the list of commands I've created on this router so far. Access list 1, I put the 200.200.200.2, then the wildcard mask, and then I also use host command. I should have used one. I just needed to demonstrate to you guys that either of the two will work. So let me remove one. I don't need the two. Let me remove this. Okay, it's going to already be in my history, so there's no point. So guys, guess what? That's standard access list. But guess what? The guy denied based on source IP address. What if what we are trying to do is not to deny this guy completely? We want this guy to talk to computer C, but we don't want this guy to talk to computer D. It simply means we need to state the source and state the destination. We will say you can talk to this, or you cannot talk to this, but you can talk to every other person on the network. In other words, we specify the source, we specify the destination. Standard cannot do that. And at the same time, because you went and blocked this thing on the other side, you know that you're going to waste your CPU of your router. What if I want to block this thing on this side? I could have created my extended also. Because extended, the rule of the extended state, you should apply it on the source interface. I can create my extended and block this guy from the source and say to any destination. Let's do that. Let's do that before we now filter. Let's do the same thing that we have done now. They use extended to block this guy from going to any destination. Watch out. Extended is a little bit more, it's flexible and it has more work. So let's get rid of the access list we created now. No access list 99. Do show access list. Let me get out here. Show access list. You see the access list is gone. Then I'll go to that interface where I apply the access list and get rid of that thing. So I'm removing everything I've done now. So this is the command we use to apply it. So I'll say no IP access group net out. So if I get rid of everything, things should start working accordingly now. So this guy now should be able to go out. It's going now because the access list is no longer there. The guy can go out now. So this same thing we did now, because we want to apply the access list on our source interface, we can go and create extended to achieve the same result. How do we do that? Go to our global configuration mode. We say access list. Don't forget the range, 100 to 199. There's another range that we spoke about in the curriculum. Is it 1000 to 1099 or something like that? So if I like, now I can say access list 100. Watch out now. Access list 100. The next statement is permit or deny. What do I want to do? I want to deny this guy. Watch out. There's something different from extended now in comparison to standard. Watch out now. In extended, we have to specify the protocol. So for instance, now in extended, I can decide to say, I'm just blocking this guy from pinging. I'm blocking this guy of anything that has to do with UDP. I'm blocking this guy of anything that has to do with TCP. But if I intend to block TCP and UDP, which is a combination of everything IP and all these other stuff, I will just block IP. So the point I'm making is I can select the protocol I want to block. So since I want to block this guy of all protocol, I have to specify the protocol. That is part of the flexibility of your extended access list. You can pick the protocol you want to block the guy off. Maybe I don't want the guy to download. We're going to come to that later. I can say I'm blocking FTP. Okay, I spoke about it in the last class. Okay, so for now, I want to block this guy of everything, meaning you are not going anywhere. So I'll say IP because all other protocols are inside of this IP. I will say access list 100, deny IP, host 200, the 100, the 100.2, hello, this is my source. The next thing is to which destination. I can select a particular destination, which is the network address, the network where the guy is going to. Or I can say, do not talk to another host on another destination. But what I want to do is I don't want this guy to go to any other destination. That becomes my destination statement. So I'll say access list 100 deny IP host 200.100.100.2. Then that should be any. Meaning what? You can't go deny this guy from go to any destination. I hit enter. So what's the difference in extended? Anytime you are creating extended, you must tell us about the protocol. You must tell about destination. If you don't mention either of the two, it's not going to work. Let me show you. Let me remove this statement and do it again. And then try to put it back. Now, I've put the source now. If I try to hit enter now, it's telling you incomplete command. Why? Because this extended works with both source and destination. If I remove this protocol now, it's not going to work. So when you are creating extended, you must specify the source, you must specify the protocol, you specify the source, you specify the destination. Same thing we did earlier. Now we are doing it with extended access list. We don't want this guy to be able to go out. Now this is extended access list. Where are we going to apply this thing? Guys, I need you guys to write. On our router, we have G00 and we have G0/1. Where are we going to apply this? Based on the rule of extended says it must be applied closest to the source. You should talk to me now. I need you to type. Based on the rule. Ali, can you hear me? Okay. Based on the rule, where are we supposed to apply this access list? The rules for extended says it must be applied closest to the source. This is our source. This is G00. This is G0/1. This is destination and any other future destination. So between G0/0 and G0/1, where are we supposed to be apply our access list? On G00 or G0/1. Now we are creating extended. Am I communicating? Are you guys flowing with me? Okay, G0/0. Thank you. G0/0. You are very correct. So is it going to be inbound or outbound? That's the direction now. You tell me the direction. On G00, inbound. Yes, beautiful. So let's go to the G00. Now I can still show you. We have created the access list, but we are yet to apply the access list. So can this be CSD ping? Can it go out? Let's find out. See, it's still going out because we have not applied the access list. It's still going out. We've not applied the access list. So now I will go to my router, go to G0/0 and apply the access list. Interface G0/0. Now, this is extended. We're going to say IP access group. What is the number? 100. Because we are referring to inbound traffic, we are going to say N. I hit enter. If I go to my computer now and do the same thing that I did before, you see that the guy is now having destination unreachable. Not because the route is not in the routing table. We are telling the router, don't allow this guy to go out. That destination we are trying to go to, is in the routing table. So we are filtering it out. If you want to go to the other guy, he can go. Why? We're filtering it out. How do we filter it out this time around? We use extended. But when you are creating extended, you must define the protocol. You must point to the destination. So extended can filter based on source IP address and destination IP address. It can filter based on protocol, source IP address, destination IP address. Is this clear? Thank you. Is it clear, people? Yeah. Well. We're going to get rid of this access list again. We saw that we have been trying to ping two addresses. One is 101.2, the other one is 101.3. We can change this thing again and say, we are not saying this guy should not talk to people on the other side, but he can only talk to one person and not talk to other. And let me tell you something before I proceed. When you are creating access list, sometimes you have multiple statements to create. So you are going to deal with specific first before group and then general. What do I mean by that? You want to block somebody, that person is specific. That means the deny statement has to come first. Or you want to permit somebody, that is specific. That means permit statement has to come first before deny will follow. So you deal with specific first, before group, before general. But right now we have 200.100.101.2, 200.100.101.3. I want to make this, I want our computers to be able to talk to this guy, or not to be able to talk to this guy, but to talk to every other person on the network. So I will start with deny statement for this and permit any other person. So I will specify the source, I'll specify the destination. Let's do it. So let's get rid of the access list we created already. So I will still use 100, access list 100. What do I want to do? Deny IP. And let me tell you something. When I say deny, okay, let me finish this statement before I explain it. Deny IP hosts 200.100.100.2. That is the source. To talk to who? Host 200.100.101.2. So if I hit enter right now, what I'm simply saying is this: any conversation between this guy and this guy is forbidden. Any conversation. But sometimes you can decide to say, no, I'm not saying they should not talk. But when it comes to remote logging, Telnet, or when it comes to downloading, maybe that 200.100.101.2 is a server. I don't want this computer to be able to download, or I just want to block ping, or I just want to allow ping. That is when you begin to manipulate this protocol. You can say, no, I'm just denying ICMP to that server. Any other thing the guy can do. Or I'm just denying FTP, or I'm just denying Telnet. I'm going to show you some of those examples. But right now, we're denying the guy from everything. So if I stop there, everybody will be denied because of this implicit deny. Let's check it out. I'm trying to deny 200.100.100.2, and it has been applied. What did I mean by it has been applied? That one we applied before will still be working because I didn't remove it, and the number is the same. So I don't want my computer to talk to .2. This computer, I don't want it to be able to talk to .2 on the other side, but I want it to be able to talk to 101.3. Let's find out if you can talk to 101.3. Let's find out. PC, hey, can you even talk to 101.2 first? Let's find out. Destination unreachable. So what about 101.3? Destination unreachable. And that was not our intention. Our intention was just to block the guy from talking to 101.2. But the guy should be able to talk to 101.3. But we have not come down and say permit, talk to any other person. If I go to PCB also, you will see the same thing. PCB2 will be blocked from going out to talk to people. Destination unreachable. But we didn't block this guy. How come this guy couldn't go out? Implicit deny. So going to go back to our router and say, watch out, access list 100 permits when it is extended. When it is extended, look at what you do. Permit IP any. What are we saying? Permit any other IP address from any destination from this, that is our source now. Any IP address from this source to any other desk, let them talk to them. Say, this is the only guy we want to block. Sometimes you can say permit IP, then host to any destination. That means it's only that guy that will be permitted. But now we want, our concern is not with any other person, but we want to free every other person. And we hit enter. If I go back to my PCA right now, you see that PCA cannot talk to 101.2. The PCA should be able to talk to 101.3. Can we see it happening? So we have used extended access list to filter based on source IP address and destination IP address. And what's our statement? We're denying communication between this host and that host. But sometimes you can deny communication between host and the network or network and the network. That is not a big deal. Let me yank up this access list and do that one for you. What if I'm trying to refer to, no, let me not remove it. Let me just show you how to do that one. If I'm trying to refer to the whole network, I will say access list 100, deny, IP, host, 200, 100.100.2. To go to anybody on the other side, everybody. So I'll specify the network address of that side, 200.100.101.0 with a wildcard mask of 0.0.0.255. What am I saying? I am denying this guy from talking to anybody on the other side. And this is their wildcard mask. Because the subnet mask is 255.255.0, so I inverted it. And that is going to give me 0.0.0.255. If I hit enter right now, this computer will not be able to talk to anybody on the other side. So the point I'm trying to make is this. Sometimes you want to allow host to host communication, host to network communication, or host to group of people's communication, or you want to probably permit, or you want to deny. Also, the other way around, it can be destination to destination. What do I mean by that? What if you have a scenario like this? What if you have a scenario like this? Let me give you an example. You have a router here. There is a LAN here, another LAN here, and then another router on the other side, a LAN here, a LAN here. So I want, let's say this is LAN A, this is LAN B, this is LAN C, and this is LAN D. What if I say, okay, I want LAN A to be able to talk to LAN C, the whole of LAN A, not just one person. But I don't want LAN A to talk to LAN D. We can achieve that with our extended access list. We specify the source, we specify the destination. You can do the same thing with LAN B. Maybe you want LAN B to talk to everybody here, but you don't want everybody on LAN B to talk to people here. This is a form of firewall. Somebody asked me that question in the last class. When you are making decisions, you are making policies, you are filtering traffic based on policies. So you can do network to network, network to host, host to host, host to group of people. It doesn't really matter. As long as you put the correct network address, wildcard mask, correct IP address, wildcard mask, everything correct, and you define the source and you define the destination. Also, let me put it here. You define the protocol, the source, and the destination. Then you are good to go. Am I communicating? Access list is wide. This is just the basic or the starting point. But people hardly use access list again because of this new or next generation firewall. So you hardly have people using access list. They just go and get firewall straight to do whatever they want to do. Okay. Mr. Samuel is saying so that we don't forget. So can we put permit statement before the deny? Of course. Let's reverse our access list that we created. Let's reverse. That is a good question. You just give me an idea now. Let me get rid of this. And then this access list that I created before. You remember we are denied this computer. from talking to this computer. Huh? So it can talk to .3, it can talk to .4, and the rest of them. Now, the reason why I use deny first is because there will be other computers, others on the network. So don't forget specific first before general. So I can as well get rid of this statement. And come down and say access list 100. Permit IP 200, sorry, host 200.100.100.2 host 200.100.100, I mean .101.3, and hit enter. Do you know what is going to happen? I don't need to come down and say access list 100, deny IP any. Implicit deny will catch up. So this guy will be able to talk to this guy, but he can't talk to any other person on the network. If that is my intention, this is specific. I want to deny this guy from talking to every other person. Then I start with permit. Then I don't have to come down and say deny any because of implicit deny. Let's test run it. So our router should be able to talk to, our computer should be able to talk to 101.3. Let's find out. Somebody say, let's check. I like that. You know, this is why I like lab. No matter how tired I am, it is very easy for me to teach some labs because you've been showing people how things work. So let's see if the guy can talk to 101.2. He's not going. What about 101.3? He's going. Who said let's check? Have you seen it now? Yeah, Ali. Ali, have you seen it? So this guy will not be able to talk to any other person on the network except the IP address that we permitted from our statement. So that's why you take care of, and this probably may not be your intention. Your intention may be, oh, I want this guy to talk to .3, .4, .5, .6, .7. That is becoming plenty. So you cannot use, you may not have to use permit first. That's why you need to decide first. You deal with specific first, then followed by group, then followed by general. So if the people you are permitting are just few, you start with permit, and then the rest are general, then you now end with deny. If the people you are denying are just few, you start with deny first and then permit later. But anytime you do permit, don't bother saying denied, don't bother creating denied statement. Please, guys, don't forget, we're supposed to be applying it, but because it's the same access list number that I'm using, that's why I didn't bother going there. If you forget to apply it, it's not going to work. Exactly. Thank you, guys. So let's proceed. See how I can finish this. Somebody was telling me that, oh, this is CCNA, no, they finish. That's why they pay CCNA people a lot of money. If you have CCNA and you know it very well, you make money. So let's get rid of this access list and do something else. It will soon be done. No access list 100. So let me be sure that I don't have any access list again. Show access list. Nothing. In fact, let's go to that interface and get rid of the one we have applied. No. What's that statement? IP access group. Yeah. So don't ever forget your direction, inbound or outbound. Don't ever forget direction. It's very important. So sometimes you want to, you are not planning to block everything. So possibly what you have in mind is maybe this is a server here. Let's make this guy a server. And you don't want people from this side. Maybe they are student network to download anything from this server. Maybe it's an accounting server. Nobody here. You don't want them to come here. Maybe you have other section. You want those ones to come here, whichever way. But let's first of all what we did. You don't bloody care whether they ping or whatever, but anything that has to do with download, which is FTP, that is what you care about. Everybody on this network. You don't want them to talk to this server. This guy is 192. 168.101.2. So how can we use access list to do that? We can use access list to do that. So this time around, we want to block which protocol? FTP. Go back to our OSI model. FTP runs on top of TCP. Don't forget, Telnet runs on TCP. SNMP runs on TCP. HTTP runs on TCP. So on and so forth. So let's create the access list. Or you don't want people on that network to be able to browse the internet. Let's start with that one before we come and do this one. So I'll go to my router. I don't want people on that network to be able to go to the internet at all on my network. Access list 100. Deny TCP. Watch out. 200, 100, 100, .0, 0, .0, .0, .255, any equal 80. Hit enter. What does that mean? I am going to deny port 80. Port 80 is HTTP. You guys should know that one now from our OSI model. Port 80 is HTTP and it runs on top of TCP. So I am pointing to the protocol, not IP as in general. The protocol is, the application layer protocol is, but it's HTTP. Or at the same time, I may not use port number, I can use HTTP. Oh, this one doesn't take HTTP. Let me check it. Oh, so it takes www. Okay, www is the same thing as 80, so ports 80. So what I'm trying to do right now, I am denying everybody on this network, everybody, from going to any destination to do what? Anything that has to do with www. What is www? That's browsing. Then I will go to my, if I have any other network there, I can come down and say access list 100 permit IP any. If there's any other network connected to that router on that segment. In fact, let's do that one now so we don't create trouble for ourselves. Access list 100 permit IP any. So what I'm trying to tell my router is this. I am just blocking these guys. Now this is extended, same way of applying. Interface G0/0 IP access group 100. If I am done with this, do you know what is going to happen? Nobody on this network, nobody will be able to go to the internet if I'm connected to a service provider. I have blocked them from going to the internet. What did I block? www. And I blocked the whole network. So there are some scenarios where you don't. Yes, you have. Now, most people use port 443. That's a good question, Ali. Most people use for port 443, which is HTTPS. I don't know if this one supports 443. I will try it and see. So you have to block them separately. You can see, I will show you how to go do that now. So there are scenarios when you don't intend to block everybody on the network. You just want to block few set of people on the network. And there are scenarios where you want to block them based on time. That is what will take you to what we call time-based access list. It's not in CCNA. Time-based access list is when you are done creating this access list, you tie it to time. Maybe their break time is from 12, work hour is from 8 to 12, and then maybe 1 to 4. So you create the access list and make it happen between 8 to 12 and 1 to 4. So what happens between 12 to 1? People can browse the internet. That is called time-based access list. We'll first of all create it, then we'll tie it to time. So the point I'm making is this. Sometimes you block the whole network and you point to a particular protocol. In this scenario now, www. If I don't want anybody to be able to send mail on that network, what do I need to point to? It's very easy. I just need to change my port number to port 25. Back to what we learned in OSI model, port 25, or I put SMTP. If I don't want anybody to be able to download on my network, I point to port 21. You can see FTP here. port 21. People can browse, but the moment they click something and they want to download, it will not work on my network. These are things we use, what do you call it? Access list to do. And we can also block port 23, which is Telnet. I don't want anybody to have a remote login to any other device or to a particular device on my network. I block port 23. So as you are pointing to this port, those ports represent or they stand for a service. And all of this is we've discussed in OSI model. That's why I tell people, don't throw away those basics. We're still going to need them as we proceed. Telnet runs on port 23, SNMCP on port 25, FTP port 21, and so on and so forth. So this is how you block a whole network from going to any destination. And in this scenario now, this has to do with browsing. But the one I was actually going to do for you guys before now is, let me yank up this. What if we don't want people on that network to talk to our server? Let's say it's an accounting server. I'll say access list 100, deny. What do I want to deny? FTP, TCP, everybody on that network. So you specify the network address and you put the white canvas. To go to host 200.100.101.2 and do what there? Oh, thank you, deny. And do what there? Equal FTP. Hit enter. What am I doing? I am denying everybody on this network. I'm going to this host here. It could be a server, accounting server, or whatever. Anything that has to do with download, which is FTP, I'm blocking them. And FTP runs on top of TCP. So you can put the FTP at the protocol itself, or you can put the port number on which the protocol operates. But don't forget, you have to come down and say access list 100 permit IP any. If you forget to do that, you're going to your mind will be to block FTP, but you're going to end up blocking every other protocol. Not just FTP, you block every other protocol. Now you see some access lists that will come down with permit TCP any, permit UDP any. Those are more complex access lists, but these are the basics that we need to learn in this class. And then you hit enter, and then you apply your access list. The labs I'm going to send to you people, I don't believe you'll be able to finish it before you write your exam on access list. Even me, I've not gone through those labs in a long time. Yes, Mr. Samuel, you have the floor. Okay, you wrote something. Let me read it. Yes. No, you cannot. You can't configure ACL on layer 2 switch. You can configure ACS on layer 2. I think there's ACL on layer 2 switch, but they don't call it ACL. I forgot what they call it. They call it something. I will try to find out for you, but I can't remember. Let me try something. See. Yeah, you can configure access list on this switch. And I'm surprised it's regular access list. Do you know what? After this class, I will try something because I don't think it can be applied. This particular one, I know about the particular one that can be configured. So after this class, I will try it and get back to you guys next class. Is the application how to apply it on an interface? And you can even dissimulate that and try it too. Just give me a minute, I'm coming. Yes, I'm back, guys. So I will try this, but I know there's a particular ACL I learned that one under CCNP, not in CCNA. So I will try it and see if it can be applied. Let's even do that now. We still have time now. So let's see if we can block. Let's yank up this other one that's on the router and see. So we don't have any conflict. Then we'll come back there. We still have time. Let's try it and see. So let me create ACL on this switch and block computer 1 from talking to computer 2. Let's say it's access list 100, deny IP host 200.100.100.2 host 200.100.100 no .101 .100.3. So let's see if it's going to work. I say access list 100. I mean IP any. So this computer is on fast Ethernet 0/1. That is my source now. Let me see if it can be applied there. IP access group. That's where the wireless is going to be. So you see the problem? I can't apply it. I don't know if it's a packet tracer issue or something. So that's where the wireless is here. Mr. Samuel, did you see that? But there is a particular one that can be configured on layer 2. I can't remember that access list, the way they will configure it. But I will do the research. So you can also do the research. That's a good question. Any other question, guys? So what we are trying to do is to give you the foundation, the basis of access list, give you different examples. But from the lab, you can now practice more. And let me tell you this, lab is just a way for you to master these technologies that we are teaching in this class. Every day we teach you new technology. Okay, Mr. Samuel is saying something again. No. If you don't apply, it's not going to work. If you want me to try to ping for it, I will ping for you to see. That is not, I like that. Explore all the options. That is 100 dots. 100 dots. Dot 3. You see the themselves. Mr. Samuel, have you seen? So it only works when you apply. So I will do that research and get back to you guys. Okay. So any other questions, guys? Any question? I was saying something about lab. Lab is the only way. If I teach you something in the class right now, if I spend 2 hours to teach you, I can bet it with you. By the time you are going to sit down and do the labs on that topic, that technology, you may end up spending 4 hours because you are just learning the technology. You are trying to apply it, and that's what will cement that knowledge for you. But if you don't practice, na lie, it won't work. You think you know everything now. It's easy. 777, thumbs up, everything. By the time you want to start practicing, you look as if they're not even talking about some things like this. But when you practice the first time, the second time, the third time on a particular topic, it becomes yours. See the way I'm teaching this topic, because I've done them again and again and again and again. So that is just the best way to go. All right, any question? If there's no question, I will just show you how do we convert our access list to named access list, like the standard we first created. We could have done it in such a way that we don't use number, we use name. And then we'll say IP access list standard. You can say standard, you can say extended. Look at it. IP access list standard. So if I say IP access list standard and it's the name, sorry, let's say new ACL or just new. Let me say just new. So the name I am going to use to apply this access list is new. Then here I can create my statement. Remember, I will say access list 10, deny. This time I will just say deny host 200.100.100.2. Hit enter. That's it. Permit any. Then go to the interface, G0/1 because that's our destination. I'll say IP access group. There's no number. New. Out. Did you see what we are doing? We created named access list or named standard access list. And we use the name to apply it, but the statement is the same. The concept is the same. If you want to create extended, it's the same thing. IP access list standard, then you give a name. Then you give your statement. Then you apply it. And that's it. To show history. Look at them here. IP access list standard. New. Deny host 200.100.100.2. Then you say permit any. Then you go to the interface, apply IP access group new out because it's outbound we are referring to. That's how you create a new named standard access list. If we like now, we can get rid of it. How do we get rid of this one? No IP access list new. I think that should be standard new. Okay, the way you put it is the way you remove it. So let me go to the way you put it. IP access list standard new. I can say no IP access list standard new. Then I can go to the interface also and just say no IP access group new out. That is how you get rid of it. So what if it is extended? IP access list extended. Then you give a name, maybe testing. Hit enter. Look at the prompt. I even forgot to show you the prompt. Here is going to show you config standard name ACL. That's the meaning of that thing. That is config STD. That's standard name ACL. In this scenario now, it's giving you config extended name ACL. So now I can put my statement and say deny host 200.100.100.2. I'm talking to host 200, no, state protocol. Deny IP host 200.100.100.2, then host 200.100.100.101.2. Then I can hit enter, and then I can say permit IP any. So the only difference this time around is we are not using number, we're using name. And what is the advantage of using name? It is easier to edit access list that has name than access list with number. How? Let me show you something. This new one I just created now. Let me switch do show access list. Watch, let me show you something. You can see that we have a sequence number 10, sequence number 20. Who put all these sequence numbers? The router. So right now, I can choose something in between and call it 15. Let me say 15. Sorry, I want to have something. I don't need to get it. If it is number, you have to get rid of everything in order for you to edit. But if it is named, you can just choose a number in between to edit. I can say, let me say, permits host 200, the 100, the 100, I mean the 100.2 host 200, the 100, the 101.3. I want to choke this statement inside that one. Oh, what did I miss there? That is the protocol now. That should be IP. They're beautiful. So if I use show access list again, you see that my new statement now, it has inputted it in between. So I just edited this access list. I am still on the access list testing. But look at all my statements. The thing puts it in sequence number 10, sequence 20. So I use 15 to choke in a statement in between. That is the advantage of named access list over the numbered access list. You don't have to get rid of everything. So you can edit the access list and by putting a new sequence number in between. All right, any question, guys? So let me get rid of this. And one more, and that will be all. Are we good? Ali, talk to me. Okay, good. One more, and that will be all. I want to create an access list to block that computer from telnetting into the router. We've talked about telnet. So I will say access list. I'll go back to my number 100. I can use standard if I like. Let me use standard. Standard. No. Let me use standard so that I can point to the IP address of the router. Access list 100. Deny TCP host 200, 100, 100.2 host 200, 100, 100.1 equal 23 or equal telnet. What is this access list going to do? I don't want this computer to be able to telnet to my router. This 200.100.100.2 is the bad guy today. It's the one we're blocking. I don't want the guy to be able to telnet to my router. And look at the IP address on my router here. So I'm dealing with my router as if it's a host on that interface. I'll hit enter. Then I can say access list 100. Permit any source, any destination, any other thing, any other protocol. It's not, this is not correct. It's permit IP. Any. Now, anytime you are creating access list to block telnet, if you remember our basic configuration, where does telnet take place? Let me see if you people can remember. Line console 0 or line VTY? Which of the line is used for telnet? VTY. So when you create an access list to block telnet, you are supposed to apply it on line VTY. So you go to your line VTY, maybe 0 to 4, whichever one, and say the command here is different. Access group, I think it's access group. No, let me look for that command. Access class. To apply here is different. Access class, then the number. Access class 100. That is the number of my ACL. Inbound traffic. I do not want inbound traffic into my router. That is telnet inbound traffic. And this time around, we don't use access group to apply. We use access class command. So if I hit enter right now, what have I done? I am simply saying I do not want 200.100.100.2 to be able to telnet into my router. That is not to be applied on a physical interface. It's to be applied on a logical interface, which is our line VTY. So it doesn't matter where you're coming from, whether you're coming through G0/0 or G0/1, anywhere you're coming from, as long as it is 200.100.100.2, you will be denied because that is a logical interface on the router. Did that make sense to you guys? Is it clear, guys? Okay, good. So that is the only difference. When you're blocking Telnet, you apply online VTY. Others on physical interfaces, whether the closest to the source or closest to the destination. And that's it. I spent almost 1.5 hours and I didn't go to the PowerPoint. These are all the labs you have in the PowerPoint. Show command, show access list, very important for you to see the access lists that are already there. And you can also go to show run also to see the interfaces and the commands applied on the interfaces, or whether it is inbound traffic or outbound traffic and all of that. You can see what is applied in this place. You can see, you can also filter that interface out using all these pipe, maybe include interface gigabit 0/0 or section 0. I think it should be include. Let me try that. Show running config, then pipe, include interface. I don't think interface works here. I don't think so. Let me try section and see. Section and see. Include. And no. So those are the aspects I've not mastered in all these pipe command. I've not really mastered them. And show access list, show running config. You can go and check out whatever you want to check. If you are something that the particular access list is not working properly, did you get the direction right? Did you create it properly? Did you get the direction right? Did you apply it on the right port? Those are things you need to consider in order for you to do troubleshooting. And that is it. If you have any question, let us hear it.